Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Mastering Data Structures and Algorithms in Java. Today's video is second part of queues. If you haven't seen the part 1, please see the part 1 first. In second part, we are now be covering the implementations for different type of queues. So in the last part, we already covered what is queue data structure. I'm not going to go through everything again. Please visit the part 1. And then we mentioned the type of queues: simple queue, circular, priority queue, double-ended queues, right? Also, where does the queue interface lies in the Java? So we can see queue interface is here, that extends collection, that extends iterable. It is implemented by priority queue, and through deck it is implemented by array deck and linked list class. Okay, so for from the implementation perspective of queues, we have three implementation. One is linked list implementation, priority queue, and array deck. In the earlier video, we already saw what these things are. We went to the details of use case examples of these things, but in this one we'll be covering their implementations. So in this part we'll cover how you can implement a linked list queue. Okay, so some of the basics again. So from the very basic example, this is what a queue looks like. Okay, you insert elements from one end, so in from one end and out from the other end. Okay, now again, as we discussed, queues can be implemented using linked list or array deck or priority queues, right? So in this video we are going to go with linked list queue internal implementation. Okay, how can we implement a linked list queue? So we'll insert the element from one end, we'll take out the elements from the other end. That's all is a generic queue. And for a linked list queue, it works in the similar manner that we have a queue, we insert from one end, we take out from the other end. So if we had the numbers 1 2 3 4, one will be inserted first, one will come out first, 2 will be inserted second, it will come out second, then third, and then fourth, just like this. Okay, but now that it is a linked list, rather than having imagining it like this, we have to imagine it something like this, that we have nodes that are attached to one another. Okay, so now we have to keep track of that these are connected. Also, to read from this end, that will be our out, and to insert on this end, that will be our in. Okay, with this, let's go into the linked list queue implementation. And if you have any questions, please let me know in the comments so I can resolve them in the next video. Okay, so let's implement a linked list queue. We have already seen the basic methods that are required for the linked list. I'll just quickly run them up again. So one is inserting, or easier way to remembering is we need to add, remove, and peak. Okay, and similarly you can add size if needed. We'll see if we add this one or not. Okay, let's go. So now that we have to implement our own linked list queue, we need our own node as well, just like we would do for a internal implementation of a linked list. So let's start with that one. Let's make sure this code is running. Okay, so we'll start with here. We'll create a node, private as node. Okay, and what do we need? From a linked list perspective, linked list requires two things in any node. One is the data. This is generally the data part, and this is the address, which actually links it to the next node, right? Let's go back. Okay, so we need node, but now when we are implementing a linked list queue, let's implement it in the generic manner. So not that it will be useful only for integers or string, but it will be useful for all the objects that call them. So we'll make it generic. If you are unaware of the generics or how they work, you can look them up, or I'll cover them in another video. But for easy understanding, generics is nothing but we are saying the data type can always be defined by the class that will be using this. Okay, so anywhere you'll use the linked list queue, it will perform directly. Either you pass integer, you pass string, or anything. Okay. So for implementing this, first we'll implement a node. So public class node, we have data. So generally we always write int data or string data, but now that we want to make it generic, we'll write t data. Okay. Now node next. Okay. Let's go. Now what else do we need to form this? We need two things, right? We have to remember that when we form our linked list, we are able to give out the functionality that there is a inside and then there is a outside. So we will remember them as the front and rear, or you can call them front here, rear here, doesn't matter, but we need this denotation, right? So we'll make two nodes specific for rear and front. Okay, so let's go. We'll say private node front. This will be for points to the front of the queue. Similarly, private node rear points to the rear of the rear of the queue. Okay. What else we need? Let's take size also, int size. Okay, that's all. Size, you know, but okay, I'll put it in comments as well. Tracks the size of the queue. Okay. Now what else do we need? We need a linked list queue now, right? So we need our constructor. So our class name is already linked list queue. We need a constructor that will initialize these objects. So we'll say public linked list queue, and what will we do? We'll say front is equal to null, just like we do it for linked lists. Rear is equal to null, and size is equal to 0 initially. Okay, so we got our constructor as well. Let me comment constructor. Okay. Let's see what else do we need. Now we need three operations. Okay, most of the thing is done. We have the skeleton. We need three operations for adding, removing, and peeking, or whatever we call it. We call it peek generally. So for adding, removing, and peeking. Peeking means we'll just look at the object, but we do not remove it from the queue, as you know from the previous video as well. So we'll make the method for inserting. We'll call it enqueue, enqueue operation. Add an element to the rear of the queue. So we'll be adding from this end, we'll be removing from this end. Okay, so let's create an enqueue method. So public void enqueue, then t data. Why t data? Of course, as we are making it generic, right? Now we'll say node, new node is equal to new node, will pass the data. Now we'll check if it could happen that this data that we are inserting is the first element, right? That would mean the node could be null, right? So we'll check if rear is equal to null. Okay, or let me also add comments here. This is to if the is empty. Okay, so if rear is equal to null, that means the queue is empty. So front is equal to new node and rear is equal to new node. So imagine it like this. We have the numbers 1, 2, 3, 4, and we have a queue. Since it's a linked list queue, we have a queue, but we only have we need to have a queue, but we do not have any node as of now, right? By default, our rear and front are null, right? By default our rear and front are null, as you can see here, right? So if we want to add the first element 1, so what we can do is we can simply create a node and we'll mark that okay, this node only is the rear and this node only is the front. Oh sorry, I rear this side and this node only is the front. So first we create a node and then we call that this is only the rear, this is only the front, since there is only one element that has been added. Okay, let's go back. So if the rear is equal to null, there was no element earlier, we already created a node with new data. Wait, why is it not taking my data? What happened? What is it saying? Expected 0 arguments but found 1. Okay, so we'll create the operation for enqueue new node new node is equal to new node, but we have to pass the data. Why is it not taking our data? Let's see, data should be taken. What's the error? Expected 0 argument. Let me okay, where is the constructor? The constructor will not expect any arguments. Why is it showing me this? Creating a new node. What did I miss? Public class node. Oh okay, I didn't create a constructor for this inner class, so I'll write this node t data. My bad, I missed it. This dot data is equal to data and this dot next is equal to null. Okay, now where are we? We added the data, front and rear are null. Now what else we want? Else, if the element or if the list already exists, or at least one element was already there, right? In this case it would be like one was already added. Let's do it this way. Okay, so we need to insert 1 2 3 4. Okay, this is just to remember a queue functionality. In from one side, out from one side. We are calling this as front, since we'll be printing from here. We'll also do the peek here. We'll call this as rear, since we'll be adding on this one. But as of now we saw that there was no element that was added, so we had created a node of 1 and we called this as the front, and the same node is called as the rear also, right? But now we are looking at the else case. That means the rear is not null, that means it is already pointing towards something. So if we want to add something, we have to add something behind this. So it would mean that we add another node, we call it 2, we link it to 1 and we call this as rear, right? So that whenever we want to remove an element, 1 will get removed first, then 2 will get removed, right? So if an element already exists in the list, we have to check and then we'll add next element on the rear side of it. Okay, let's go. Else rear dot next is equal to new node. Okay, and then first we have linked it, so we'll say link the new node at the end of the queue, and then rear becomes the new node, right? So what we did in the code is we had one node, one was already there. Let's say rear was already pointing to this, it has an option for address of the next node, so we are saying rear dot next is equal to new node. So we had found new node somewhere 2, we are saying point to 2. Okay, and then we'll say this is our rear end, so we'll say new node is equal to rear. So rear will now point to 2. That is what we wanted, right? The rear should always be pointing to the last element or the back side of it. So 1 was here, we have 2 as well. Okay. Now rear is equal to new node. That's all we need in the inner queue, right? Once again, so I'll say update the rear to the new node. That's all. One more thing is, now that an element is added, the size will increase. So size plus plus, right? Simple. So this is our enqueue method. Similar to enqueue method, now we need a dequeue method. dequeue, dequeue operation. Okay. What will it do? Remove an element from the front of the queue. Okay. Now you remember, right, that we are adding from one end, we are removing from the other end. Now we'll create public. Since it is going to return, we generally take the return type as int, but we are developing in generic. So public t dequeue. Okay. So we'll check if front is equal to null. That means the queue is empty, right? I'll go here. Is empty. So if front is null, we'll simply return null, because there are no elements, you cannot dequeue anything. Otherwise we'll say t data is equal to, how will we get the data? We'll call front dot data. Okay. So as of now, imagine that 1 and 2 are added, right? Rear is pointing here. Earlier front and rear both were pointing here. Okay. Front and rear both were pointing here. Then we added another element. Rear is now pointing to second element. Front is still pointing here. So if you want the data, we can simply say data is equal to front dot data. So we got this data 1 from here, but then we are removing it. So let's remove this node only, right? We'll remove this node. We can remove this node and then ask front to point to this node. How will we do that? How will we reach to? Because we can use front dot next. So first we get the data, we delete the data later. We get the data, we move our front to the next one. So we can say front is equal to front dot next. Now front and next both will point towards 2, right? And this, since no one is linked to this one, this node is cancelled, and then later be garbage collected, so it's deleted. Okay. So we'll say t data is equal to front dot data. Once we got the data, we'll move the pointer. Front is equal to front dot next. That's all, right? But what if the queue becomes empty after this one? What if there was only one element and we removed that element? So we have to take precaution for that one as well. So we'll check again. If, how will we check? If front is equal to null. So to understand this, let's say there was only one element. There was one. Okay. Front is pointing here, rear is pointing here, and front is pointing here. Now we are saying front is equal to front dot next. Right now whenever we make a node, the next is null. So front is equal to front dot next is null, so front becomes null, right? So if front is equal to null, that means there are no elements left in the queue. So we need to null the rear end as well, right? So if front is equal to null, so this check is for if the queue becomes empty after dequeuing, queuing, dequeuing, no, dequeuing, and that is the spelling. Okay, please let me know what's the spelling. Okay, so if the queue becomes empty after dequeuing, we'll do where is equal to null as well. Okay, that's all. One more thing, size will be reduced, so size minus minus and return data. Okay, so this is our dequeue method. We made a enqueue method, we made a dequeue method. Remember, we are implementing a queue using linked list. Okay, now what else do we need? We have covered the enqueue method, we have covered the dequeue method. Peek is left, right? So let's implement the peek. What's the syntax? Peek operation. Okay, so what will it do? Get the front element, ele element without removing it. Okay, so we'll say public, since it's going to return t peek. Now let's say after a while our queue is formed. Okay, 1 was added, then 1 dot next, 2 was added, then 3 was added, then 4 is added. Okay, this is rear, this is front. Okay, now I want to peek an element, so I should get this element, but at the same time I should not remove it. So I'll not do those things, front is equal to front dot next, and move the front to next one and get this data removed from the, get this node removed from the linked list, right? We can directly just return the data. Okay, so we want to peek if the data is there or not. So we'll just check, we'll do a null pointer check, we'll do a null check. If front is equal to null, that means the list is empty, right? So we can simply say return null, list is empty. Okay, else we'll return front, because we are getting the data from front dot data. Okay, that's simple. Now similarly, please go through the video on linked list as well. So if in case you are facing issues in understanding how we are actually implementing a linked list, because we have covered how to internally implement a linked list, right? Now we'll check for the size as well, or we'll just simply check if it's empty or not, because it will be a useful method. So let's get the size first. Okay, get the size of the queue. So we'll say public int size, return size. That's all. We'll add for check if queue is empty or not. So we'll say public boolean is empty. We'll say return size equal to 0. So if the size is equal to 0, we already have our size variable. So if the size is equal to 0, that means the queue is empty. We can simply return true. Otherwise, we also have a method for returning the size. That's all, right? So far we are good. Let's go through it one more time. We have the node, we have the linked list queue, we have implemented our enqueue method, dequeue method, and peek, size, and is empty method. So let's test it. Okay, we'll create a linked list queue. Now we made it generic, right? So we can use any data type. So we'll use integer here. We'll call it queue is equal to new linked list queue. Okay, will enqueue few elements, enqueue elements. So we'll say queue dot enqueue. We can pass the values 10. Similarly, queue dot enqueue 20, queue dot enqueue 30. Okay, we'll print system dot out dot println, let's be queue size, that will give us queue dot size. We have a method and variable named same. Okay, queue dot size, let's run it. Queue size is 3. Okay, because the queue has finally been formed, this system dot out dot println. What do we want now? Let's print front element, but we want to print the front element, we don't want to remove the front element, so we'll just use queue dot peak like we did yesterday. If you remember, we had a queue linked list. If you see this one, right, we use the existing method queue poll peak. Instead of poll, we have named them. So linked list queue has the method offer and poll, but we are making customized one. We named them enqueue and dequeue, and then the peak we named peak. Okay, let's go back to our class. Let's remove this. Yeah, so do a peak. So we had inserted 10 first, so 10 is in the front. Okay, similarly we'll do, let's dequeue, dequeue elements. So we'll say system dot out dot println dequeued plus queue dot dequeue, right? It's actually removing from the rear end. So sorry, dequeue is from the front end, adding it at the rear end. Let's run. So 10 got removed, right? Now that we have removed 10, let's remove another element. We'll use the same again. Let's run. 10 got removed, then 20 got removed. Let's do a check. System dot out dot println queue size after dequeue. We'll say queue dot size and run. Yeah, we can get the size because we have removed 10, we have removed 20, right? Similarly, we'll directly check for the last element that is there. We'll do a peak. Okay, so we'll take this statement, front element after dequeue. Okay, let's run. 30 is the only element that is left, right? Lastly, since there is one element left, we'll check our last method also. System dot out dot println, is the queue empty? So we'll check for queue dot is empty, so it should return false. Queue is empty, false. Okay, so this is how we implement a queue using linked list. We know how we can directly use a linked list queue, but this is how, if you want to implement a queue using linked list, you would implement. Basic methods are enqueue, dequeue, means adding element, removing elements, and then peaking the elements, right? Plus, one more time, in a linked list queue, insertion is from one end, deletion is from the other end. Okay, these things are done to imagine. You can actually build them in any way. You can actually keep the you can call this insert or this out, it wouldn't matter. Okay, only thing to remember it, imagine it like a tunnel. The functionality required is elements get added from one end, they get removed from the other end. It's like cars going inside a tunnel. One car went first, it will come out first. Second car went second, it will come out second, right? Just like that. Okay, in case there are still any issues, please let me know in the comments, and I'll discuss them in the comments. Okay, in next part we'll look at how we will implement a queue using an array deck or using a priority queue. So that's the second part. Will come with third part and fourth part as well. Again, this is something from the last slide only, so please this is for you guys to take a look. The summary is same. Queues are fundamental data structures that supports FIFO operations. Okay, once you understand data structures very well, it is a really fun thing to play around with. Okay, you'll realize eventually that apart from arrays and linked list, there's no extra data structures. All the data structures are formed on top of these data structures. Okay, so that's all from today's video, everyone. For anything, please let me know in the comment section. In the end, please like, share and subscribe. Thank you.